this video, we're going to go over how to solve quadratic equation by different method. The first example we're going to look at it is solving quadratic equation by factoring. We did the factoring before. So if you wanted to find out how to factor before you wanted to learn how to solve by factoring, look for my other video for factoring quadratic. So this one, whenever we wanted to solve quadratic equations by factoring, we wanted to have quadratic equation in a standard form. And standard form look like this: ax squared plus bx plus c equals to 0. So descending order on the left side, and the other side will be equals to 0. So set one side equals to 0, and the other side will be descending order. So if you wanted to do that with problem A, 3x squared minus 12x equals to 0. So from the left side, you're trying to factor. Whenever you have two terms, you can only work greatest common factor or difference of square. So it look like I do have a common factor, greatest common factor. So let me factor that first, and look like I have 3x as the greatest common factor. It means I'm going to have x minus 4 remains. Once I reduce quadratic into two linear, I'm going to use the zero factor property, which means both factor equals to 0 to become 0, right? You have to have one of the factor equals to 0 at least to have a 0 of that factor, right? So we're going to set this factor equals to 0, this factor equals to 0. And solve. So when I solve this, dividing both sides by 3, your solution will be still 0. X is going to be 0 over 3 is 0, right? That's one solution. This one right here, you're going to add 4. We just did solving linear equation from the other video. So we know this is going to be x equals to positive 4. So quadratic equation, you're going to have two solutions because quadratic become two linear, right? Or you can write your solutions to be set 0 and 4. Either way of writing your solution will be fine. Maybe in your homework system, they're going to ask you a certain way to answer it. But on a paper, either way will be okay. So if we're looking at the next one, first thing I need to do is writing into the standard form. So negative become positive when you move to the other side of equations. And this is 3 terms. 3 term is factoring trinomial, especially when your leading coefficient is 1, is easier to factor, right? So x times x makes it x squared. This means you're going to have same sign. That same sign is positive. 2 numbers to multiply 10, added to become 11 is going to be 10 times 1, right? So once you factor equals to 0, let both factor equals to 0 to solve or find your unknown variable. So you're subtracting 10 both sides. It becomes x equals to negative 10. Subtracting 1 both sides to isolate x. X is equals to negative 1. So your solution x should be either negative 10 or negative 1. Try one more. So this one is same thing, leading coefficient being 1, right? So when we factor, and this is already standard form, so just need factor. Same sign, that same sign must be negative. Factor of 36 gives you addition of 13 is 9 times 4. So x minus 9 equals to 0 gives you x equals to 9. X minus 4 equals to 0. X is positive 4. So that quadratic equation will have solution of 9 and 4. Example D, we're going to look at this time factoring when leading coefficient is higher than 1, right? So we have 2. Again, the method that I'm going to use, you can find the examples of it from different videos. We're assuming that we already had factoring. So this is solving equations, right? So when we factor 2, it will be 2 times 1. 6 is 3 times 2. When you cross multiply, you get 3 and 4. And when we are adding these two numbers, we should get positive 7. And if this is true, your sign have to be both positive, positive. So your factor is going to be, this is your first factor, this is your second factor. So you get 2x plus 3 and 1x plus 2 equals to 0. So once you factor equals to 0, then let each factor equals to 0 to find two solutions, right? And then first solution is negative 3 over 2. The second solution will be negative 2 on that problem. Right. This is just one way of factoring leading coefficients higher than 1 with 3 terms. We went over 2-3 different methods from the other lesson. So if you wanted to go back and review it, that's fine. Find for quadratic equation factoring or quadratic factoring. Let's look at the next one. Next one. Factor of 8, there are a few, but I will try 2 and 4. 3 is just 1 and 3. When you cross multiply 1 times 4, 2 times 3, and we always try to make it the middle term when we are adding these two numbers. And so in order to do that, you have to have two different sign because your C being a negative, right? And in order to get negative 10, both signs have to be negative. But remember, C negative means you have to have different sign. So with getting different sign, you cannot get negative 10. So what you need to do is you're going to use different number. What number? Well, let's rotate and see if that works, right? 3 and 1. That will be 12, and this is going to be 2. And adding it, I should be able to get negative 10 if I get negative 12, positive 2, right? And again, it satisfies this negative, having a different sign. So this factor should be negative. The factor in front of positive 2 should be positive. So your factor should be 2x minus 3 and 4x plus 1 equals to 0. Once you have two linear equals to 0, let both linear equals to 0 to solve for each solutions. So isolate x by adding 3, dividing by 2. So you get 3 over 2, and this one you get, let's see, you get 4x equals to negative 1, where dividing by 4, x is negative 1 over 4. So you have these two solutions right here. The next one we have is solving quadratic by square root property, right? We call this is one of the easy way of solving quadratic equations, but there is only certain case we can use square root property. Okay, so I'm going to show you when. In order to use the square root property, you cannot have x with x squared separately, something like this one, right? But if you have only x with square, right? X squared separately, no x on top of it, then you should be able to use square roots property. So how do we do it? So once you have only one side with square, then you can use the square roots to cancel out because they're inverse to each other, right? So when you're doing square roots one side, you need to do square root on the other side of the equation also, and make sure you put plus minus sign. When you do that, you end up getting x minus 2 equal plus minus square root of 6. And when you isolate x by adding 2 on both sides of equations, you get x equals 2 plus 2 plus minus square root of 6. That's it. That's how you're going to solve a quadratic equation using square root property. So this one, when you're looking at the second one, in order to use this method, square roots, you need to isolate x squared by itself. It means you need to get rid of subtraction 1 and division 3. Multiplication of 3 by dividing 3, right? Once you have only square terms by itself one side, you can square root both sides of equations to get rid of that square. So let's start by adding 1. Then you end up getting 3x squared equals to 48. And then you're going to divide by 3 to isolate x squared. You get x squared is equals to 3 goes into 48 16 times. Now you should be square roots both sides of equations and put plus minus sign. Square root and square cancel out. X is equals to plus minus square root of 16. We know that square root of 16 is equals to 4. So your solution for that quadratic equation is going to be -4 and +4. Let's look at one more. I need to isolate square term itself, right? So this is going to be square. It means I need to get rid of this 3. Multiplications, right? So the first thing we wanted to do is dividing both sides by 3 so I can isolate square term. Then I get x plus 4 squared is equals to 7. Now you can do square roots both sides. Don't forget to put plus minus sign on the other side. This cancels out the square roots with square. Now x plus 4 is equals to plus minus square root of 7. Again, isolate x to solve for x. Subtract 4, so it will be -4 plus minus square root of 7 should be the solution of that equation. Now we're going to look at quadratic equation solved by completing the square. So completing the square means that we're trying to make perfect square, something like this example right here. Because we know that using the square root property is one of the easy way of solving quadratic. So let's see if we can make perfect square when we're factoring and then use square root property, right? In order to do that, in order to make this trinomial into perfect square when you factor, you have a formula that you need to be satisfied, where when you have a standard form like ax squared plus bx plus c equals to 0, your a have to be 1. So leading coefficient have to be 1 in order to use this method. And your c should be b over 2 square. So long as you have a equals to 1, c is b over 2 square, when you factor this quadratic, you will get perfect square, right? So that's what we're trying to create. We usually do this when the equation is not factorable, right? Something like this first problem. This is not factorable, and this is what we're trying to recreate it. So what do you mean, what do we do with the c that we already have? Well, that I'm going to move it to other side. So I will start this problem by plug in or isolating what I will need and what I will not need in order to factor into the perfect square. So plus 1 moved to other side will become negative 1. So we still have the same problem. Remember, we're going to use b over 2 squared to create new c. And of course, your leading coefficient have to be 1, and it's already 1. So that's one thing that we don't need to worry about. And then your new c is going to be on this problem. So it will be, your b is 8. So it will be 8 over 2 square, which will give you 4 squared 16. So you're going to add 16 and add 16. In order to make this equation not change from the given problems, you need to add both sides by same number, right? So then when you do that, when you factor this trinomial, it will give you perfect square. It's going to be x, same sign. The same sign must be positive. Square root of 16 is 4, right? So right before you square, that's the number you're going to use on the factor, right before you square to get c. So it will be 4. And we know 4 times 4 is 16. 4 plus 4 is 8, right? So that will be the right factor. Now the other side is going to be negative 1 plus 16, so it will be 15. Once we create into perfect square, now we can use the square root property. And simplified, you get x equals to negative 4 plus minus square root of 15 for that problem. I'm going to try one more, similar to that one. So again, your leading coefficient have to be 1. That's satisfied. And you cannot have c. Your c have to be b over 2 squared. That's the formula you need to memorize in order to use the completing the square. So I will not need the c I have. It means negative 5. I will move to the other side. That become positive 5. And new c will be b over 2 square. And this b is going to be negative 2 over 2 square, which is going to be negative 1 square, which is 1. So you're adding 1 on both sides of equations. And when you factor this, you get perfect square. X, same sign being negative. 1 times 1 is 1. 1 plus 1 is 2, right? Square. 5 plus 1, 6. Use the square root property now. And that will give me x minus 1 equal plus minus square root of 6. I isolate x by adding 1. You get x equals to 1 plus minus square root of 6 for that problem. Once you understand how it works, it's not really bad. Just remember what you need to do, creating new C, right? So this formula will be important to remember, right? We not only use completing the square by solving, we're going to use the completing the square to graph parabola, graph circle, ellipse. So we're going to end up using completing the square method a lot. So it's important to remember that formula. Okay, so this one, our leading coefficient is not 1. So we're going to start by making that. How? Well, let's see if I can divide both sides of equation by 2. Then I will end up getting x squared minus 2x minus 1/2 equals to 0, right? So first thing I need to do is making leading coefficient 1, and I did that by dividing both sides by leading coefficients. And I'm going to rewrite this without the C. So it will be x squared minus 2x. Negative 1/2 become positive 1/2 on the other side. Your new C is going to be using this B right here. So it will be negative 2 over 2 squared. And that gives you negative 1 squared, which is 1, right? So you're adding 1. And we did this before, so when you factor it, it will be x minus 1 squared. This gives you 1/2 plus 1. In other words, it will be 1/2 plus 2 over 2, right? 1 become 2 over 2. So that's going to give you 1 plus 2, so it will be 3 over 2. And use the square root property. And I get x minus 1 equal plus minus square root of 3 over 2. One thing you need to remember, if you have radical in denominator, you need to get rid of it. That's one of the rules that you cannot have. So this one, when you multiply both sides by square root of 2, numerator and denominator, to get rid of square roots, you get square root of 6 over 2. So your x should be positive 1 plus minus square root of 6 over 2. If you want to have a same denominator, you can also write it as 2 over 2 into 1. So it will be 2 plus minus square root of 6 over 2. So any of this solution will be the same, right? Any of this will be the same solutions. One other way of solving quadratic equation is using quadratic formulas. So in order to use the formula, you need to know the formula, right? If you have a standard form, ax squared plus bx plus c equals to 0, then x is equals to minus b plus minus square root of b squared minus 4ac all over 2a. And this is quadratic formulas, right? Quadratic formulas. And that's another one you need to memorize if you are intent to use the quadratic formula in any time, right? So if it's not factorable, you can either use quadratic formula or completing the square. If it's not factorable, these two should work anytime. So you need to know one or the other. But when we're graphing it, we're going to use the quadratic, completing the square more. So I guess if you're asking my opinion, this is a little more important because you end up using this more on different problems. But some people think this is easier. So it's up to you which one. Or both. It's fine, right? So the first thing we need to do in order to use quadratic formula, we wanted to set it into the standard form equals to 0. So -1 become +1 on the other side. So your A is going to be 2, B is -6, and C is +1. And let's replace it into the formulas. So it will be -B plus minus square root of B squared minus 4AC all over 2A. Once you replace it into the formula, you just need to simplify. So this is going to be 6 plus minus square root of 36 minus 8 all over 4. And simplify further, square roots inside should be 36 minus 8, so it will be 28 over 4. Square root of 28, you can simplify it again into, so this, let's see, square root of 28, 2, 14, 2, 7. So 2 of the same number. So it will be 2 square root of 7 over 4. You see the common factor 2 here, here, and here. So it will be 3 plus minus square root of 7 over 2 is the simplest form of your solution. Let's try that one more time with the next problem. Again, you need to make a standard form equals to 0 by moving everything into the left side. You wanted to make your leading coefficient positive if you can, because that's usually easier. And you're probably used to doing it, right? Where A is 1, B is -3, C is -5. Replace it into the formula. You get -B plus minus square root of B squared minus 4AC all over 2A. Let's simplify that. It becomes +3 plus minus -3 squared will be 9. And because you have minus one of the negative number, it will add 4 times 5, 20 all over 2. So this is 3 plus minus square root of 29 over 2. And square root of 29, you cannot simplify it any further. There is no two same number. This must be your solutions for that problem. Using quadratic formulas. But if you end up using completing the square method, you will end up getting the same solution for same problem. Because solving quadratic equation is so important. Why? Because no matter what types of equation you're going to get, you wanted to reduce that equation into either linear and quadratic and solve from there. So if you know how to solve linear equations and you know how to solve quadratic equations by any method, then if you learn how to make given equation into either quadratic or linear, then you should know how to solve it from there, right? So the next example we have is solving quadratic equation by any method. So I'm going to show you how or which method I'm going to use, but you probably did with different method, getting a same solution. That will be perfectly fine. What I will do when I see this first problem right here, I don't even know if this is going to be quadratic or linear. First thing I see is the parenthesis. Whenever I see parenthesis, I wanted to get rid of it, right? So that if I have a like term, I can combine them to make it a simpler form, right? So in order to get rid of parenthesis on this problem, you're going to do foiling. So 2x times x, 2x times 1, negative 5 times x, negative 5 times 1, and then you want it to make one side equals to 0, so subtract 2 equals to 0. Let's combine the like term. That's going to give you minus 3x and minus 7 equals to 0. Look like I'm going to deal with solving quadratic because I see this square as the highest exponents, right? So once I see quadratic, then I need to see which method. I have a factoring method, square root property, completing the square, quadratic formulas, right? I have 4 different ways that I can solve this if this is factorable, right? Usually when my leading coefficient is higher than 1, using the quadratic formula will be a little bit simpler. Completing the square, I need to start by dividing by 2 to make leading coefficient 1, right? So this one, I will use the quadratic formula. Then I will have minus b. And if you keep using them often, you will just memorize the formulas. Minus b plus minus b squared minus 4ac over 2a. And when you simplify that, you get 4 times 2 times 7, 56 over 4. Adding this. $65, no 2 same values, so that must be it for that solutions. So look like it wasn't factorable. If it was factorable, you will not have square roots on your solutions. So it's good that we start using quadratic equation without factoring, right? When leading coefficient is higher than 1, usually quadratic formula is the easiest way to go. Let's look at the next one. What about if I see fractions like this? Then the first thing I wanted to do is multiply something to get rid of all denominator at the same time. So my LCD of this denominator will be 4x times x plus 3. If I multiply this to all the fractions, I will get rid of all the denominators. So I'm going to write that down. So for 1 over x, I'm going to multiply by 4x times x plus 3 plus 1 over x plus 3. I'm going to multiply by 4x times x plus 3. equals to 1 over 4. I'm going to multiply by 4x times x plus 3 over 1, right? So that I will get all denominator. So then x and x cancels out, denominator 1, denominator 1, denominator 1. So no more denominators, right? What's left over? I have 4 times x plus 3 times 1. And then I have 4x times 1. And then I have 1 times x plus 3 remains. I see parentheses, so let's distribute to get rid of parentheses. 12, 4x, x squared plus 3x. Look like I'm going to have quadratic equations. It means I wanted to make it standard form equals to 0. So once I combine these two, move to other side because I wanted to make my leading coefficient positive. So this 2 will be positive 8x. Move to other side. Become negative 8x. And then positive 12 to other side, subtract 12 equals to 0. Simplify this, x squared minus 5x minus 12 equals to 0. So if my leading coefficient is 1, right, I have 1 here, I will either use factoring or completing the square. And maybe this is not factorable. So if it's not factorable, then completing the square means 12 move to other side. And I will have adding b over 2 square, which my b on this equation is negative 5. So it will be 25 over 4. So then when I factor this trinomial, I get x minus, right before you square to get 25 over 4. In other words, square root of that will be 5 over 2, right? Square is what I'm going to get. And I need to do addition of this. And we know that 12 will become 48 over 4 because I need to have the same denominator, right? Which will give me you get 73 over 4. So when you square root each side, I get x minus 5 over 2 equal plus minus square root of 73 over 4. So my x should be equals to 5 over 2 plus minus square root of 73 over 2. Because the same denominator, you should be able to write it together. And that should be the solution of that problem. So don't forget, having a formula, quadratic formula, and completing the square, we should be able to solve any types of quadratic equations, even if it's not factorable.